Hello viewers, welcome to my channel Connect Civilians. So in this lecture we will see how to design a rectangular footing with uniform thickness using the Excel sheet. Okay, so these value that was showing in the dark green, you have to provide all these value, and after that all the extra value will be calculated by itself using the Excel sheet formulas. So here the load, so you have to provide the load, unfactored load, okay, which you will get from your result. If you are designing in STAD or A-type, you can get the load from there only. Now this will be your FBC, that is safe bearing capacity of soil. So in my condition it is 150 kilonewton per meter square. Okay, column size will be 452 by 300. So in this you have to provide the longer side of column, and this you provide the shorter side of the column. Okay, now unit weight of the soil. So unit weight of soil is 18 kilonewton per meter cube. Generally this value will be taken for unit weight of soil. Depth of the footing I am considering it as 1.5 meter. Grade of concrete is, we are going to take 20, that is M20 grade, and for steel it is Fe415. Okay, so now initial values we have provided here. Now all the value will be calculated, that is self weight of soil 27 kilonewton per meter square, total weight including the self weight of the footing, that is 550 kilonewton, and area of footing will be calculated as 3.67. So we have already done the manual calculation for uniform rectangular footing. Okay, so you can go and check if you want to see design procedures manually. Okay, so here our size of footing is calculated as 1.84 multiplied by 1.99. So we are going to take, here you have to provide the size of footing according to you. So this will give you the idea that what size will be taken. So this is the minimum. Okay, so because of check for one way and two way here, we have to provide the higher value. Okay, so I'm going to take the value as 3 by 4, that is 3 the width and 4 will be the length of the footing. Okay, so now our area is 12 meter square, which is greater than our calculated area, so this will be okay. Step 2 will calculate your net upward and gross soil pressure. So here net upward is calculated by your given area. Okay, so if this will show you not okay, so you have to increase the size of the footing. Okay, if it is okay here, so you can further go with the same size of footing for the next calculation of bending moment and shear force. Okay, so now it is also calculated, and it is less than our SBC, so this will be okay. And gross soil pressure will be calculated after the calculation of your total depth. Okay, so you have to check again after the calculation of your depth what depth you have taken, so that will decide your gross soil pressure is okay or not. If it is not, so you have to increase your area of footing again here, that is 3 by 4, so you have to increase it. So this value that was given here, so all the calculation will depend on this area. Okay, so software will take these two values, the size, width and length of footing. Now so bending moment will be calculated, UDL along x direction, UDL along y direction, critical section, and all the value will be calculated, and ultimate bending moment for y and x direction will be shown here, that is 295.37 kilonewton meter, and for bending moment along x it is 227.81. So here you don't have to do anything. After that depth of the footing will be calculated, so it is inserted in the formula here only. So you don't have to change any formula, or you don't have to see any code in this Excel sheet. It will directly calculate according to your Fy and FCK. So what value you have provided for Fe and FCK, that is grade of concrete and grade of steel, according to that its formula will be calculated, and depending on that your effective depth for x direction and y direction will be calculated. Okay, so here our effective depth is calculated for x direction is 144 mm and for y direction it is 189 mm. So we have to provide higher value so that our effective depth will be greater than these values. Okay, so we are going to take our overall depth as 400 mm for footing. Cover will be taken as 50 mm. So if you are providing the PCC below the foundation, so it is okay to take the cover as 50 mm. But if you are providing with if you are not providing any PCC before that, you are directly going to the foundation, so you have to take the cover of 75 mm. Okay, bar of diameter for first layer. So for first and second layer I am going to take the bar as 12 mm. So what is first layer, what is second layer, I will show you. This will be the section of your footing. Okay, so the orange one is the first layer, that is main bar, and the green one is your second layer. Okay, now our dx and dy effective depth for first layer and second layer is calculated as 344 and 332, which is greater than 144 and 189, and it is okay. Here it is showing you shape. Okay, so don't have to do anything. If you will go with lower values 200, so see it will show you the effective depth in y direction is not safe, so you have to increase the value. So I am going much higher value because of the checks that we have to perform after the reinforcement, that is one way and two way check. Okay, so here you have to just fill these values that is showing in dark green. Okay, after that what you have to do, you have to check the reinforcement, so these value will be calculated. I've already shown in manual class that how it is calculated. So here your dx sorry if you're still in x direction and you're still in y direction, that is still in first layer and still in second layer will be calculated, and minimum still will be coming as 1440 mm square. So your steel should be greater than this, otherwise you have to take this value. So here it is okay right now here, so you don't have to do anything. So number of bar required will be calculated as 22 number of bars. Okay, so I'm going to take one higher value, that is 23 number of bar. Why? Because if you go with 22 number of bar, it will show you the area of 2487 mm square, which is less than your ST required. Okay, so you have to take the higher value of that, that is 23 number of bar, which area will become as 2600. So that will show you okay. You need to check your red boxes, either it is showing you okay or safe or not. Okay, if it is not, so you have to again change the value according to this. Now the spacing, so our spacing for each direction is calculated as the center to center spacing is 131 and clear spacing will be 119, which should be less than or equal to 180 mm. Why? Because according to your steel, if you provide Fe415, so your spacing should not be greater than 180 uh, mm, and it is mentioned on IS code 456 page 56 table 15. You can go and check from there also. So here we are providing Fe415. If you provide Fe500, so see here I will show you, so your spacing will be decreased, so your spacing should not be greater than this value. So according to this, software will calculate. Okay, Excel sheet will calculate. Now we are going with Fe415 here, so that will be okay. And here again it changes, the value will be changes, so it should be less than this, so it will show you okay. Okay, now what you have to do, if you it will show you not okay, you have to increase the number of bars. Okay, always remember. So similarly you have to check, go for check for steel in the second layer. So either you can just follow the same number of bar as in first layer, or you can also calculate and again check. Okay, so here our second layer bar is calculated as 17 numbers. So what we have to do, if you go with 17 number only, it will show you not okay as area is coming less, but if you go with 18 number of bar, it will show you here okay as area will increase more than the required one. But what will happen here, if you see the spacing, clear spacing, it will show you not okay, because our spacing is 270 and which is more than 180 mm, so it will show you not okay. So again you have to increase the bar. So still you have to provide the 22 number of bar, then it will show you okay. So you can directly go with the same number of bars, that will also correct. Or if you want to go with accuracy, you can also check with this. Okay, so now you have to provide 22 number of bars here. Okay, now so for second layer, what IS code has suggested, that if you are going with the central bandwidth method, if you are going with rectangular footing, so there are two methods, so you have to provide if you want to go with this. So central bandwidth reinforcement, so if you see the second layer of reinforcement, I will show you here. So the green one is the second layer of reinforcement. Either you can go directly with the same number of bar all over the surface. For first layer it was okay, you have to provide the same number of bar in both the condition, but for second layer, that is for green bars, if you are following central bandwidth method, so you have to check this central bandwidth, so you have to provide the spacing according to this. So 12 number of bar, sorry, 12 dia of bar, you have to provide the spacing of 159 and it should be between the range of 3 meter, that is the equal to the width of your footing. Okay, so this is 4 meter, this is 3 meter, so according to this you have to provide the central bandwidth reinforcement up to 3 meter. Okay, so this from center of the footing, it is 3 meter equal to width of the footing, and up to this you have to provide the central band reinforcement, and it is coming as 12 diopter at the date of 159 center to center. Okay, and at the balance section for the green bars, you have to provide 12 at the rate of 180 Okay, so you can either go with this or directly go with these values, both are correct. The changes will only occurring for the green bars. Okay, either you can just directly go with the same number of bar for all the area, or you can go with central bandwidth method, that is also correct. Okay, but here similarly here you can't provide the spacing more than this, that is minimum spacing will be 180, sorry, maximum spacing will be 180. So you have to go with the 180 bar, which is much more higher area that we have provided, that we have to provide for the balance section. So this will also be okay, and if you are going with directly with same bar for second layer in all the sections, so that will also be okay. Now everything will be okay here, so we are going for check for one way here. So all these value will be calculated here. All you need to do, you have to just check from the table 19. Okay, so this will be a table 19 of IS code 456. This will showing you the area percentage of reinforcement, and this is showing you the grade. So here what you have to do, so our percentage still is 0.252, which is coming between 0.25 and 0.50. Okay, so if you go with if you want to go directly, so you can go with 0.25 direct value, but I will show you how to do the interpolation if your value will coming much more between these. Okay, so here our value is 0.25, 0.252 and 0.50. So here we have provided the interpolation box. You have to just insert the value 0.25 and for the calculation of 0.252 percentage and 0.50, and our grade is M20, so our value will be 0.25, 0.50 will be 0.36 and 0.48. So you have to provide the value here 0.36 and 0.48, and this value will be calculated, and you have to insert this value to table num in this box. Okay, manually. So only this value you have to insert, and all the your design strength check and design shear strength will be uh, checked here, and it will show you shape, that will be okay, you don't have to do anything. Okay, now check for two-way shear. So this will be calculated all the value, that is the perimeter of your uh, for two-way section, that is at distance of d by 2, effective depth by 2. Okay, so your perimeter is calculated, area will be calculated, and section will be find here. And here you don't have to change any value. All you need to do, you have to just check this is safe or not. How this value is calculated, and we have already done the manual. You can go and check. I will provide the link in the description or end of this video. Okay, so tau c dash, so this formula will be taken for the calculation consideration, and it is shown in ISO 456 page number 5859. Okay, so here it is saved, so we can go further. Check for transfer of load at the base. It is mentioned on page number IS code 456 page number 65. So both the values calculated and actual bearing stage will be find, that will be both the same, so you don't have to provide any extra bar. Our forces can be transferred through bearing will be 1215 kilonewton. So and our our factored load will be 750 kilonewton. So 750 is much more less than our factor load that bearing uh, that that is considered to take the bearing. So up to 12-15 kN of load, the footing will transfer. So no extra dowel bar is required here. So if the transferable force value will less than our factored load, so if our transfer load is 50, assume, so extra dowel bar will be required here, and you have to provide the die of the dowel bar that is coming from the column. So generally we take the same value for the dowel bar. If the number of bar is less, what bar is coming from the column. So if from column it is 20 mm dia bar is coming, so we will provide the extra dia bar of same dia. So number of bar will be required as 2. Okay, but here it was okay, no extra dia bar required, so you don't have to provide any extra dia bar in footing. Okay, and our development will be calculated as per ISO 456/26.2.1. So you have to give the dia of the dia bar, that is dia of the bar that is coming from the column, and here you have to take the percentage as a it is a deformed bar or mild steel bar. Okay, according to this you have to increase the percentage, and here your LD will be calculated as 940 mm, and your available length for footing is the 603, which is greater than 940, so it is also sufficient to go for the design. Now if you want to check the development length for more detail, I will provide the link in the description of that video. You can check how all the development length in tension and compression will be calculated. Okay, so after checking all the values and it is safe or not, you have to go to check the footing design data here. So this will be the data after all the checks. You have to see, so what footing size will be provided, what cover will be provided, and what dia bar we have to take. So here it is showing you safe, that will be okay, and what steel bar you have to provide. So if you are not following the standard bandwidth method, so you can go directly with this. So first layer will be provided as 12 mm dia bar at the rate of 131 center spacing, and second layer provided as 12 mm dia bar at the rate of 185 center spacing. Okay, and if you are following the center bandwidth method, okay, I will just change the color if you are, so you can't be confused. Okay, so here if you're following center banding method, so in second layer you have to change according to this. So in the place of 12 at the rate of 185 center spacing for all the periphery, what you have to do, you have to provide that 12 mm at the rate of 159 center spacing at the center band of the footing, and at the balance section you have to provide 12 mm of dia bar at the rate of 180 mm center spacing, because maximum you have to go with the 180 mm spacing. Okay, so in this figure here we have shown you how to provide the reinforcement. Okay, so here For first layer we have given 12 mm at the rate of 131 mm center center spacing throughout the footing in this direction, that is x direction, like this. And for y dash direction you have to provide the green layer at the rate at of 12 mm at the rate of 885 185 mm center to center of spacing, or using the central bandwidth if you are following, so you have to change only in second layer of bar, that is for middle section up to 3 meter, that is equal to your width of the footing. You have to provide 12 mm at the rate of 159 mm center to center spacing from center up to 3 mm, and at the balance section you have to go 12 mm at the rate of 180 mm center to center. Okay, so this is how you can provide the reinforcement and all go through all the checks using the Excel sheet for uniform rectangular design of centric footing. Okay, so if you like this video, please subscribe to my channel. Thank you.